And last I think we have seen about the regular expression, and we have used regular expression when we had a demo where we have seen class where we could use regular expression, right? We could use pattern matcher, right? We have used scanner there for taking input, but yes, there we used input stream and output stream, right? We specified that yes, a bank clerk can be created from a bank object plus a input stream and output stream. The idea of input stream was, okay, the source from where input will be available, the commands will be supplied, and output stream, the place where we want the responses to come. Fine. Okay. So anyway, so let's now begin with the next topic, which is related to the java.io package. So we want to now cover the java.io package. Okay, so this is about java.io package. Fine. So initially we'll take an overview of what is there in the java.io package. Okay. Now for that, the first thing, the majority of the thing, what is here in java.io package is related to the stream classes. Now don't confuse this with the streams which we have already seen. The stream which we have looked at are the streams for objects, when they are not the IO streams. Okay, this is about streams related to IO. Fine. So java.io package is there right from the beginning, and right from the beginning we have the concept of streams. Stream which we have seen so far earlier, fine, we had seen earlier, fine, was related to what is introduced in Java 8, stream based processing, but that's a different thing. Fine, now what we are looking at is streams of Java.io. Okay, fine, two separate things. Yeah, so don't link at all with the stream which we have seen earlier. Okay, so streams in the java.io package classified mainly into 4 categories, okay, based on 2 criteria. There are 2 criteria for a stream. Fine, how the classification of stream has been done. So streams classified into 4 different types of streams, okay, based on 2 criteria. What are the 2 criteria? So we have streams being categorized based on, one is the direction of the flow. When we see, whenever someone talks of a stream, that means there is some flow. And it indicates a flow. Okay. Based on direction. So there are 2 directions, in direction and the outward direction. And the other is either based on direction, and it's also another one which is based on type of data which flows. Fine, these are streams in which based on type of data. Right. When someone says type of data, it would be binary data or it would be text data. And when someone says binary, it means it's a byte stream. When someone says text, it's a char stream or character stream. Okay. So streams categorized into 4 types based on 2 criteria. What are the 2 criteria? What is the flow? Direction of the flow. Fine, stream indicates a flow, right? So inward or outward. When someone says inward, means getting something, the application wants to get something from outside. Okay, inward into the application. Fine, from somewhere getting data into the application. Out means application has data which it wants to send out. Okay, that's the out direction. Fine, application decides to send it out. So it would use some stream to do it. Okay, fine. So that is direction, and other is what is the kind of data which is going to flow in the stream. The type of data, it can be binary stream or we call it as a byte stream. Either you call it as binary or byte stream, and the second type is text data or you call it as a character stream. Right? The data type of Java, primitive type called char, stream of chars. Okay, fine. So let's look at it. How we have? What are those four stream classes? So the four top level stream classes. We have four abstract classes here. Okay, fine. So yes, so let's divide this. So based on these two criteria, so one we can look at direction. So one is inward direction, and the other is outward direction. So that's your direction part. Okay, and other thing is related to the type of stream, which will be it's a byte stream or it's a char stream. Okay, so that way we get four stream classes. The one which is a byte stream and inward direction is known as input stream. So we got a class called input stream. We also have a class called output stream. And these two are byte streams. And equivalent character streams are, we have a class called reader and we have a class called writer. We got a reader and a writer. So that way these are the four stream classes. These are the four top level stream classes. Right. Okay. Fine. These are four top level stream classes. Okay. Okay, fine. Let's continue. And so what we have here, based on two different criteria, one is the direction, inward and outward. Other is based on the type of data which will flow in the stream. Clear? Byte streams and character streams. So that way we get four different classes. Fine. So we have got these four top level stream class. We call them as top level. Fine. These are, they have got, each of them has lot of subclasses under it. Fine. So what java.io package is full of, it's mainly full of subclasses of these four. Fine. What we have in java.io is these four classes and lot of subclasses of them. Fine. Each one has subclasses. So we'll be looking at those also. Fine. But there are, other than the subclasses of these four, there are other classes also, some classes, some other useful classes and interfaces. So let's have a look at them, those things also, right? So other than these four stream classes, what we got in java.io package over and above all this, one of them is an important class called, we have an important class called the file class. Okay, fine. File class, it can be used for managing the files in your file system. Okay, managing files in the file system would mean it's not about reading and writing. Okay, it's not about doing input output from a file. It's about managing the files. You want to delete a file, you want to rename a file, you want to get information about the file, you want to change some setting of the file. Fine. It's about those things. Fine. What's the last modified date? If there is a directory, get me the listing of the files in the directory. Fine. All such information. That's what the file class. So file class, of this file class is used for file management. Okay, so that's one thing we have used for file management and managing files in the file system. Okay, related to this, of course, when we take the listing of files. As I said, okay, if there's a directory, you can ask for the listing of files in a directory. Fine, you want to know that. So there, you may not be interested in all the files in that directory, you would like to filter them out. Okay, so for filtering purpose, there are two interfaces which are useful here. So we have interfaces like the file name filter, and another interface is the file filter. Okay, fine, we have the file name filter and file filter, some useful interfaces, fine, which will be used along with the file class, can be used along with the file class.
File name filter and
File filter are interfaces. And this, what we are looking at is just an overview of what is there in the java.io package. Fine, we start with the overview, and then what we'll be looking at later, mainly in this particular classes, we'll be mainly looking at the file class. Today we would like to explore what is there in the file class. Okay, fine, managing files, that we'll start with today. Okay, fine. Other than this, now if you look, see, we have those 4 top level classes. Yes, we can, if I use an input stream, I can read from some source. Fine, I should be able to read. Input stream means for used for reading, fetching data. Fine, output stream means sending out, and they are classes here. So look at a file. What is a file? If I consider a file, is it used only for reading, or is it used only for writing? No, it's used for both purposes, right? You read and write, do both the things from a file. When you open a file in read-write mode also, and then maybe you read some data, go further, write some data, fine, clear? So for being able to do reading and writing both from a file in the same, using a single object, if you want to do such a thing, no, we can't do it with a stream. We do have stream classes which can read and write from a file, but they are separate classes. Or there'll be a separate class called file input stream, which allows you to read from a file. You have a separate class called file output stream, which allows you to write into a file, and that too sequentially, right? Okay. What we have is another class, another useful class, part of the java.io package. There is a class called the random access file. This class has capabilities which are both reading capability as well as writing capability. So you got methods of both kinds of things. And how does it get methods of both the types? Okay, to have methods of both the types, fine, we have this class implements 2 separate interfaces. So there are 2 interfaces. One interface is giving all kinds of read methods for it. Okay, those methods are available because of an interface called data input. And we have another similar interface which has capability of writing. That's a data output. Reading from the file or writing from a file. Fine, methods for reading available in random access file. So random access file basically is implementing both of these. And so those 2 are related interfaces. And these are interfaces implemented by random access file. Okay, we have these interfaces, data input output. When I consider a data input, it has all kinds of methods to read any type of primitive data type, primitive values. It will fetch primitive values for us. Okay, fine. So fetching primitive values is okay. It deals mainly with primitive values or at the most some strings. Okay, fine. Same way, data output deals with all primitive values only, writing primitive types, primitive values, primitive data types of Java. Fine. But then we have got objects also. Fine, we have created object, and sometimes you might be interested in storing the objects. So being able to persist an object or save an object and being able to recreate an object from what was saved earlier, putting it in the same state as it was earlier. I don't want to call the constructor and create an object. I had an object earlier, I have saved it maybe in a file or some other place, some persistent storage is there. So I have saved an object, fine, I have terminated the application, I restart my application. When I restart my application, Let me see if that file exists. Let me recreate the object as it was in the last time. And you may be interested in doing such a thing. You don't call the constructor and fine. If you call constructor, it is in the initial state, right? No, I want it in that state as it was, right? When I actually saved it. So being able to save and recreate an object, and those capabilities are also available through another interface. So we have this interface called data input and data output, and we got some a separate set of interfaces. So we have another interface called object input and oops, object input and another interface which extend. So this is the one, like object input extends from data input. Same way we have another one which is object output as extending from data output. Okay, object input extends from data input and object output extends from data output.
So random access file is a class.
Is a class.
Data input, data output,
Are interfaces implemented by that specific class?
and object input and output is
Are interfaces. They are interfaces which are extending the corresponding data interfaces. And they are just there extending from the corresponding data interfaces. Okay. So here we are talking about what? When I say object input and object output, we are talking about persistence of objects. Object output means yes, you should be able to save an object. Fine. So when we persist an object, what we do is we use a technique which we call as serialization of the object. What is being done? Serialization of an object is being done. We serialize an object and then we are able to save it. Okay, fine. So this process of serialization which is there would be available to only those types, those kind of objects which implement an interface called serializable. So we have another interface here called serializable. And we have, and this just to get an overview of what is there in the java.io package. Yeah, so what kind of things exist in the java.io package? Fine, mainly full of stream classes. Those 4 top level stream classes we have seen. So lot of subclasses of each of them. Fine. Input stream, output stream, reader, writer, they have got their own subclasses. So that's one thing which we have in the Java.io package. Another thing which is related to the file management, we have the file class. Related to that, there are a couple of interfaces which we have seen. Fine. Plus, we have another class called the random access file. Okay. Fine. And then we even have classes, interfaces which are implemented by random access file called data input and data output. Data input, data output interfaces which are implemented by random access file provides capabilities of read and write for mainly all the primitive types. So we don't want to be restricted to only using the primitive types for reading and writing purpose. We would like to extend that capability to objects also, and those are provided by an interface called object input and object output. So yeah, that's what we have, and we have an interface called serializable which is related to those two. Fine. Clear what kind of things we have in the java.io package. Okay, plus and some place we even have a class called, like, it's related to when we open anything for reading or writing or read write both. Fine, maybe a file or anything. When we open any file, right, when we open a file for reading or writing, what is being done is, from the OS side, what is done, we have a file descriptor allocated for our process. Okay, there's a file descriptor which has to be allocated. So we do also have another class which is in part of the same package. There's also a class called file descriptor. Yeah, we do have this class also. Yeah. Okay. Fine. Now, fine. So today what we'll be doing is we'll be mainly looking at the file class, this one. Okay, that's what we want to look at today. Okay. So fine. Let's look at the file class.
So file descriptor.
Yeah, file descriptor is just a class. Right? Whenever we open a file for reading or writing, right, a file descriptor would always be allocated.
So उसके methods.
We're not looking at any other thing. We're only looking at the file class today. Right? It's not about reading or writing from file. File class is not about reading or writing from a file. It's not about I/O. It's not about input output from a file. It's about managing the files. Clear? So we are looking at management of files now. Managing files in the file system. Of course, now we have other options also for managing files in the file system. Okay, there's something which has come from Java 7. Yeah. Okay. Okay, so fine. So let's look at this. What is a file object? An object of file represents an abstract path in the file system. Some abstract path in the file system. Okay, fine. What is a path made up of? If I think of any path, yeah,
Folders, directories.
you have got lots of name components and a separator. When you have a separator, right? Uh, the separator is, of course, platform dependent. On Windows, you'll have backslash as your separator. On Linux system and Unix systems, you'll have slash as the separator. Fine. Fine. So yes, there's a file separator. So as far as the file class is concerned, we do have these public static. Yeah, we have this public static final as a string. You have a variable called. Fine. So this is common, and we have got two variables. There's one variable called file separator. Okay, the value would be, what's the value for the file separator? It would be different on different platforms. Clear? According to the platform, you'll get the value. Okay, so one is file separator, another one is path separator. What is path separator? I'll give example here. Okay, examples for this file separator. What are the examples? Slash for, it is going to be slash for Unix and backslash for Windows. What is path separator? It's going to be colon for Unix and it's going to be semicolon for Windows. Oh, when there are multiple paths to be specified, semicolon is used for separating them, right? So that's your path separator. So these are available as string, so as string constants, or we even have another one which is, and this is okay. We even have public static final type is char, and the variable is, the name of the variable is file separator char. The type is char, that's the only difference. Same way we have the other one which is the path separator char. Fine. Which has the char type. Instead of string type, if you are interested, you even have the char type also. So these values are anyway available all the time to us. Okay, fine. These are static variables in the file class, public static variables. Okay. Now talking about the file object of the file class. When an object of a file, okay, object of this class is nothing but a abstract path in the file system. Fine, it's made up of those components, the names which are there. Now, there are two ways you may specify a path. You write it as a relative path or as an absolute path. Fine. On Linux system, if you start with a slash, you are giving absolute path, starting from the root. Or if you don't start with a slash, start with some name, that would mean you are giving relative to the current directory. And relative to current directory is the directory from where you start the execution of your application. Fine. Okay. Fine. So it's nothing but a path only. Fine. Now the methods. Talking about methods of the file class, or let's begin with the constructor. How do I create an object of file? So to create an object of a file, we have various constructors. You can create an object of file by giving a string for the path. You can specify the full path here, okay, which could be relative or absolute, whatever terms you like to have. Another way to create would be, you can create a file object by giving two parts, giving it in two parts. You can say string, you give a path to a directory and then another string, which is the file name within that directory. Okay, here's a path to a directory and then you're saying, oh, that's the file name in that directory. And you can specify in two separate parts also. Okay, see, when you write a path, it could be a path to a file or it could be a path to a directory. And the path can be to a file or can be to a directory. So file object can be representing a file or a directory, path to a file or path to a directory. Okay, so you can also create a file object where you have first one as a file object. There's a file object which is representing some directory, and relative to that directory you want to specify your file name. Okay, so that's another way of creating a file object. And if you have some file object already which is representing a directory, that can be used as a first parameter for creating a new file. Right? It's just about path, okay? It's not about physical file yet. You can create an object of file and there need not be a corresponding physical file being present over there. Okay, it's not necessary. It's just a path. You can create an object, give any path and just create an object. Fine. So once an object is created, now you invoke method on this object to interact with the file system. Fine. See, it's like this. You got your file object created. It has some kind of a path in it, right? When I invoke a method on it, at that time it will go to the file system and get information and take actions there. It can take action. And this is simply an object having a path. It's not, this object is not the physical file. It's separate from a physical file. Okay, fine, it's separate from a physical file. Okay, so let's look at the methods now. Fine. So on this object, I can say, okay, whatever path I have given, do we actually have something in the file system like this? Whatever path I have specified, is it physically existing at all in the file system? So we have a method called method to return a Boolean value, method called exists. Okay, if it exists, oh, I might be interested in knowing, is it there as a directory or is it there as a file, right? So we have method to return Boolean is directory. Fine, another one is file. So you can find out whether it's a directory or it's a file. And this path is actually physically there as a directory, it's physically there as a file. And that can be distinguished. Okay, whatever it may be, you might be interested in getting more information about that, right? What kind of information? For example, in case of Linux and Unix systems, you might be interested in knowing the permissions, the read, the write, and the execute permissions. So we have methods like this which can return Boolean value. We have a method called can read. Similarly, we have can write, and we have the method called can execute. So these are the methods which will let you know whether you can read, write, what permissions you have for this file in the file system. Fine, whatever that path is, right? What kind of permissions do we have? Read, write, execute. Okay, fine. In case of Windows platform, okay, in case of Windows platform, you might be interested in knowing the attribute. Fine, we have the attribute called read only. Fine, we have the attribute called hidden. So you might be interested in knowing those attributes. So we have methods to return Boolean. We have the method called is hidden. Is it a hidden file? Is read only. Fine. See, we have these methods can read, can write, can execute. They have to tell us whether this permission is there. Now, if you got appropriate permissions, you means the application, when we start the Java application, fine, that user, if it has got appropriate permissions, then it can even change these settings. Okay, these settings can then even be modified. So for example, in case of can read, right, we also have another method to return void. Okay, the name of the method is set. No, the method doesn't return void. The method rather returns Boolean. Yeah, here again the method returns Boolean. So we got setter methods corresponding to these. So we have method to return Boolean. Name of the method is set readable. Parameter is a Boolean value. Fine. So you can change the whether can read setting, right? Whether you can read, fine, that read permission. If you got your permissions to change them, you can change the setting. You can make it true or false. Set readable. So fine, same way we have other method called set writable. Fine, with the same parameter which is your Boolean. And we even have a method called set executable. Fine. So this read, write, execute settings can even be updated if you got your permissions correctly. Fine. If you got appropriate permissions, you can even change the read, write, and execute permissions on the file. And we have methods for changing them. Fine. Same way, the hidden and the read-only attributes can also be updated. So we got methods called set hidden. You pass a Boolean, change the setting, true or false. Fine. Same way, another Boolean would be set read-only. You can pass a Boolean value and change the read-only setting. See, hidden and read-only are more applicable to the Windows platform, fine, and the other three attributes, they are related to the Unix and the Linux platform. Read, write, execute permissions. Okay, let's look at more methods here. Fine. Okay, so getting more information about a file, that's a permissions, right? Read, write, execute permissions. Then what else about a file? What information you might like to know about a file? The size of the file, fine. When was it? What is the last modification date time? So yes, all those things are available. We have method to return long. Name of the method is length. So that can tell us the size of the file in number of bytes. Return type is long, 64-bit value. Okay. Length method. Fine. Size in bytes for the file. Same way, another method to return long, name of the method is last modified. Okay. Last modified returns long. What is that long? It is the time in milliseconds. When time in milliseconds since 1/1/1970, 0 hours of UTC. Fine, or IST, not IST, sorry, 0 hours of GMT. We call it as UTC rather. Fine. So last modified. 1 milliseconds, number of milliseconds since 1/1/1970, 0 hours GMT. Fine. This value can always be, this long value can always be used to create, mainly you can easily create this, you can use in the constructor for creating a object of java.util.date, fine, or you could use it even in the java.time package. We have those classes, and we have various classes in the java.time package also. And now from Java 8, there's a new package called java.time. We have the classes for local date, local time. Fine. So this value can be used, easily be used in those classes also to create objects of those time. Okay, so last modified, time in milliseconds. Fine. Of course, there's another one here. We do have a setter method. So we have method to return Boolean set last modified. You can change the last modification date time. Parameter would be a long, the time in milliseconds, and the time in milliseconds. The time in milliseconds has to be specified. Pass it along, and you can change the last modified value. Fine, changing the last modified date time for a, so that attribute can be changed, last modification time. Okay, so length, date time, what else? The name itself. See, when we create a file, how we have created, maybe using absolute path, using relative path, or you can even find that also. For example, we have a method to return Boolean, and whether it is, how this path was created is relative. Is this a relative path, or is this a absolute path? And we have is relative, is absolute, these kind of methods also.
Relative or absolute path will be
Yeah. For example, if you put a path as ABC slash XYZ, it's a relative path. This is a relative path. But if I put a slash, I start with a slash, that's sufficient. Slash, and then even if I say slash ABC slash XYZ, that's an absolute path.
a physically existing path.
It's not about physically existing. Because you start with a slash, you have given that yes, this is from the root. Slash means you are specifying the path from the beginning. When you don't start with a slash, this path is in your current directory. Where is ABC assumed? Oh, whatever is your current directory, there ABC which we'll be looking at. Right? So that's an absolute or relative. Fine. What way you created the path? File object. Using a path which is relative or using a path which is specified in absolute terms. Okay, so you can know absolute or relative. What else about a file? About a file object, about a path. It may have been created with relative or absolute. Whatever way you may have created, let me know the absolute path. I want the full path. Though I have created like this, maybe, right, as a relative, yet I want the full path. Fine. I want to know the exact path where it is. So it would be prepended with the current directory path, right? So that can also be done. So you even have method to get, you have a method to return a string, get absolute path. Get absolute path. Get absolute. I think the method is get absolute. When someone uses get absolute path, even that's a method. Fine. For get absolute path, the return type is a file. For get absolute path, the return type is a file object, whereas someone can always use the get absolute method. It would return a string. Get absolute returns a string. Okay. And let's look at, there's so many methods here. Let's look at other methods now. Yeah, so it's about absolute. Now coming to that file, the path again. The path divided into two parts. The last component in that file, the last component part, the last name is actually the name of the file. Before that is all about a directory, right? In this directory, so and so file name, right? So we have method called get parent to return a string, and there's another one called get parent path. If I say get parent path, the return type is a file. So from this file, from this current path, whatever is that path in the file object, give me the parent part of it as a string or as a file object. Fine, you can ask for both, either of them. Okay, so get parent and get parent path. We even have a method called get name. If I use the get name, it returns a string. This is nothing but the last component, the name of the file. Fine, excluding the parent part. Okay, not the directory part, but only the name part. Okay, so we have a method called get name. Fine. Okay, so find lot of method fetch information. Okay, now there are methods. Yes, we have seen few setter methods already. They make changes. They make changes in the file system. They are changing the settings. Fine. There are other methods also which will make changes in the file system. Okay, first thing, oh, whatever that path is, you are interested in deleting the file. You want to delete a file. Oh, this path, whatever is there, just delete the corresponding file in the file system. Fine. Returns boolean. Delete. Delete the file represented by this. See, it's representing a path. I'm just saying delete, no parameters. Delete this. Here, the physical file from the file system will be deleted. Fine. Then what else? Then you might have, yeah. What else can be there? Like delete, we have another method called, okay, whatever that path is, I want to create a directory out of it. It's not existing, I might be interested in creating a directory. So we have the method called mkdir, returns boolean, make directory, and create a directory out of it. Or another method is mkdirs, make directories. That also returns a boolean. The only difference between mkdir and mkdirs is, for example, if someone says, let's take this path is /abc/xyz. Now, if someone wants to say make directory there, okay, the /abc must exist. It will only create one further directory. mkdir is just going to create only one further directory. If abc doesn't exist, it fails. Fine. But if you use mkdirs, if there are earlier path which is non-existing, it will try to create them all. Clear? Fine. Make directory or make directories. Okay. Fine. You find this is something which was non-existing, and you would say, okay, let me create it as a directory. You might like to create it as a directory, or you might be interested in creating a file. So we also have a method called create new file. A file of size 0 would be created. Fine. File with the size of 0 will be created. Create new file. Fine. It's not about reading or writing, okay? No reading or writing. Fine. Not the data being read or written. It's managing just the files here. Fine. Then what else? We have done delete, we have seen making a directory. Fine. You can also do another thing which is about moving a file from one path to another path. And the name of the method is rename to. We have this method called rename to. Parameter is another file object, the destination. Rename a file. And you want to rename the file. What you need here, current file to be renamed to what? What it is to be renamed to has to be specified as another path, another file object. And it has to be, so you need to create a file object first for the destination also, then pass it in the rename to method. Okay, fine. It's a file object and not a string which is required in rename to. Okay, fine. Now another thing is, you got a directory and you want to know the list of file names in that directory. What are all the files in that particular directory? Right? So for that, yes, we got some methods, and let's put it in the next page. Okay, so when continuing with those methods of the file class here, we are still continuing with the file class. Okay, You want to get the list of all the file names in a directory. The method is simple. The method would return a string array. Right? Names of the file in a directory. Name of the method is list. Fine. So it returns an array of string containing the names of the file. And another method, fine, but this method is returning a file array and not the string array. This method is list files. Fine, we have the method called list files. List method would return the names of the files, whereas the list files would return array with the file objects corresponding to all the files in that directory. It's not giving us only the names of the file, it's giving us the file objects here. Clear? If we have the file objects, we have more information, right? We can know anything about that file now. If I get a string array, it's just giving me the names. Okay, so it's always a better option. Most of the time, it's a better option to use the list files method. Okay, both of these methods are overloaded. Fine. So if you want, you can get a list of files by using a filtering criteria. So you can say, I want the list of files which are returning true for the method implemented by file name filter. You got a file name filter. Fine. Oh, same thing. You could get a file array by using the list files method, and parameter would be a file name filter. I'm first listing out the overloaded forms, and then we'll discuss what is that file name filter. Fine. And yet another one which is available for the list file. As far as list files is concerned, we also have an option of using, instead of file name filter, we might use a file filter as well. So we got both the options with list files. When list files anyway is a better option, and here another option is either to use file name filter or the file filter. Again, there we'll find it's a file filter which is a better option to use rather than using a file name filter. Okay. An example for using the list files, or let's use the file name filter and file filter both. As an example, let's see some example for this. What is this file name filter? Yeah, both of them are interfaces. Let me put both of them here. So if I say file name filter, okay, it's an interface which has one abstract method. So fine, so we can use lambdas here. Okay, lambda expressions can be used. Okay, earlier we used to write anonymous inner classes here. Fine, but now from Java 8 we even can use lambda expressions, and that would be preferred also. So the file name filter has just one single method to return a Boolean value. And name of the method is accept. It has two parameters. First parameter is a file object to represent a directory, and second parameter is a string with the file name. Name of the file within that directory. So two parameters in the Boolean in the accept method here for file name filter. Whereas if I look at a file filter, okay, that also has a method to return Boolean. Name of the method accept, but parameter is only one, file object, single file object in file filter. Fine. There are two interfaces, right? Okay. At this place, yes, we are able to use file name filter. Another place we got even file filter. So that way we got two interfaces. One is the file name filter interface, other is the file filter interface. Both of them have the same method called accept. Fine. Both of them are exactly same information. Only difference here is this is file object, single parameter. Fine. Whereas this is like breaking it into two parts. The parent part and the file name part has been extracted out of it. So it's giving us two separate things. And whereas this is giving us straight away the file object. It's like if I, in the accept method of this file name filter, if I use a constructor to create an object using this directory and the file name, it will give me a file object. I can create a file object by using file in a string. So if I use that, I actually get this file. Okay. And a very simple example here for looking at the file name filter and then the file filter. Okay. For the file name filter, we can have okay, let's say I'm interested in getting a list of all the Java files in a directory. So I'm assuming I already have some file object representing some directory D, let's say. Okay, so there's some file object representing, sorry, representing a file D. Oops. Okay, so we got file object D. Fine, it may have been created using some mechanism. Fine, it's representing a directory, and I'm interested in getting all the Java files out of it. What are all the various Java files in that, in this directory? So you can get it by using a file array. So let's use a file filter, list files method. So we have a file array. Let's call this as Java files equals d dot list files with a parameter where I'll pass a file name filter initially. Let's see how we do it with file name filter. So with file name filter, what do we have? A lambda expression which takes two parameters, some directory and some file name. Fine. And then that lambda is simple. Okay, so given the directory and the file name, your expression is just saying, okay, so I should return, I will only accept those where the file name dot ends with dot .java. Yeah. So if the file name ends with dot .java, fine. That's what is acceptable. Fine, that's how you can write. Okay. Now someone has a different criteria. Someone says, oh, I'm interested in all the small files. Small files maybe are the files whose size is less than 1K. Files whose size is less than 1K. If I'm interested in those, so yeah, what you might do here is I'll say, okay, let me have a file array. Let me call it as small files equals d dot list files. Okay, again we'll have the parameter as a lambda expression, a directory and a file name. Fine. Now look at this lambda expression which I have to write. In this lambda expression, what we'll have to do is we'll have to create a file object first. Only then can we know the size. Fine. We have to look at the size of that file, but the file is nothing but something which we derive by combining these two. Okay, so your lambda expression may go like this. Okay, start braces, and then we'll have file f equals new file created by using the directory and the file name, and then you can say return f dot length is less than 1024, then it's a small file. Yeah, you'll have end braces, and then you have the end of the method like this. Yeah, it would look something like this. Fine. Whereas instead of here we have used a file name filter. Instead of using file name filter, it would have been much simpler to use a file filter, because in file filter I could have just same thing, small files could have been got by using list files with parameter being a single parameter f, and it's the expression is simple, f dot length straight away, right? F dot length is less than 1024. That's it. Yeah. You already have that combined thing. When we are using file filter, it's a combination of the two things. What is available in file name filter. So file filter would always be a better option. Okay. And so clear methods, and this covers most of the methods of the file class. Oh, there's another static method which could be useful for Windows platform especially. There's a static method in the file class, so a separate method now. There is a static method to return a file array. Name of the method is list roots. What does this return? See, in case of Linux, there's a single root always, slash is the only root. Whereas in case of Windows file system, no. Roots. What are all the roots? The drives. Oh, you have C drive, D drive, E drive. Fine. What you may have. So, what all drives do I have? You want to know that? List roots. It returns a file array. Those root paths, just the root path, C colon backslash. For that path, there's one object here in this array. D colon backslash, that's another object. And it's an array with all the drives. Fine? Array with root of all the drives. Okay? Fine. There might be a few other methods. Okay? Fine. But that's what is mainly used. Okay? Fine. Length would be useful. Those getting those properties, last modified, fine, get name, all such things will be useful for us. Okay? Fine. So, fine, we can have some small exercises. One exercise could be to just give a list of files in a given directory. Okay, and another one could be related to searching a file recursively in some directory. So you have a directory, so maybe I'll just what we want to do, right, as an exercise here is we want to have a static method, let's say, right, which can return a list of file objects. A list of file objects. The name of the method could be find file, right, where the parameters are, first parameter is a file object to represent a directory, and second parameter is a string. Name of a file to search. Okay, so search this file name in this directory, and not only that directory, in any of its subdirectory, wherever it occurs, fine, all the places where that particular file name occurs, fine. So we want list of such file objects. So if I look at the absolute path here, yes, the name of the file here would always be that file name. That's the kind of list we want to return. Fine. This can be done maybe more easily with recursion. Fine. That second one and this one. This exercise here. Okay. And first exercise is about getting a list of files in a directory. Fine. So take command line argument as a name of a directory, and you want to just list the print the list of files in that directory. When I want to print the list of files in that directory, I would like to see the date and time followed by the size of the file and then the name of the file. So that way I want a listing here. And so we want to have such listings. Fine. So two exercises for this. Fine. Okay, so we can continue next time. Fine.